In this video, I'll be going over the final exam study guide, which covers chapters 8, 9, 10, and 14. So in chapter 8, we learned about confidence interval estimates. Our first problem here is a confidence interval estimate of a population mean when the population standard deviation is known. So number 1, KPBS is interested in estimating the mean number of minutes per day that children spend watching TV. The population standard deviation is known to be 21.5 minutes. KPBS selected a random sample of n equals 200 children and found that the average time watched by children was 191.3 minutes. To develop a 95% confidence interval estimate, what is the margin of error? So the first thing we want to do for this problem is to find the critical value that we're going to be using for our formulas. And so the critical value will be based on the confidence level, in this case, the 95%. And in the study guide at the top here, I have a table with the most common confidence levels for our Z critical values. So at 95%, our Z is 1.96. From here, we can go ahead and solve for the margin of error. Note that over here on the right, I do have the formulas, and this here is the entire formula for a confidence interval estimate. But the question asks, what is the margin of error? So recall that margin of errors have a plus or minus in front of it. In other words, here's my plus or minus, so the margin of error is the right side of the formula. So I only care about this part right here. Our critical value times our standard error, which is the population standard deviation divided by the square root of n. Now we can solve for the margin of error by using our calculator or by using Excel. So for the final exam, I provide an Excel file that has all the content you need. There's a tab specific for chapter 8, a tab for critical values and p-values that you need for chapters 9, 10, and 14, and there'll be a tab with some regression data that you'll run for the chapter 14 questions. So here we are on the chapter 8 tab, and up at the top we have two formulas for finding the margin of error. One is when we know the population standard deviation, and one is when we don't. And if you'll notice towards the right here, I also have the formula for the margin of error. In problem 1, we know the population standard deviation, so we're going to use the formula up here, which is based on the normal distribution. That's why it says equals confidence.norm. So typing in equals confidence.norm, the alpha, and I have a note that says alpha is 1 minus the confidence level. So in this problem, our confidence level was 95%. So 1 minus 0.95 gives us an alpha of 0.05. The standard deviation was given to us at 21.5 minutes, and the sample size is the 200 children. Making sure I have all my numbers in and hitting enter, I get 2.98. So if you'd rather use a calculator, all we would do is enter our variables into this side of the formula. So my Z value of 1.96 times our standard deviation of 21.5 divided by the square root of the 200 children. And that will give us the same answer as Excel, which is the 2.98. And of course, there's the plus or minus in front of it since it is a margin of error. Our next problem here is a confidence interval estimate of a population mean when the population standard deviation is unknown. IHOP took a sample of 25 customers and recorded how long each occupied a table. The sample mean is 1.2 hours, and the sample standard deviation is 0.3 hours. The population standard deviation is unknown. What is the 95% confidence interval estimate for the mean number of hours a customer occupies a table? So the first thing we want to do here is because we do not know the population standard deviation. That means we're going to be using the t distribution. You can see that here in the formula why our critical value is now the letter t, because this is the t distribution. So what we have to do first is to find the degrees of freedom, which is n minus 1. In this case, our n is the 25 customers, and minus 1 gives us 24. Next, we'll find the critical t value by going over to Excel. So at the bottom here, the label says finding the critical t value when population standard deviation is unknown. So again, the Excel file is labeled very clearly about which formulas are for what purposes. So we're going to be using this one right here. So typing in equals.inv.2t, it asks for the probability, which in my note states that the probability is 1 minus the confidence level. In this case, we are working with a 95% confidence, so 1 minus 0.95 gives us 0.05. And then the degrees of freedom we previously found was the 24. Double checking my numbers, I'll go ahead and hit enter, and we get 2.0639. And then we have the option of using Excel to find the margin of error or using the formula. In this case, we are looking for the confidence interval estimate, so we are working with the entire formula. The point estimate in front plus or minus our margin of error on the right side. And so we're finding the margin of error when we don't know the population standard deviation, which you can see is this formula right here. And so we're going to be using the t distribution. That's why the formula says equals confidence.t. So typing in equals confidence.t, I'll enter my alpha. So that's the 1 minus the 95% confidence level. So it'll be 0.05. The standard deviation was given to us at 0.3 hours. And then the sample size is the 25 customers. Checking my numbers and then hitting enter, we get 0.124. And you can always move the decimal if you need to see more values or less values. So if you prefer to use a calculator over Excel, you can just plug in our variables into the formula here on the right. So my sample mean is the 1.2 plus or minus. The critical t-value we found was the 2.0639. The standard deviation, that's the 0.3. And then the square root of our n or our 25 is right here. And then what we do is we solve the right side or the margin of error on its own. And that'll give us that 0.124, just like we found in Excel. Now for the confidence interval estimate for the exam, I'm going to leave it in this format right here. So I'm not going to ask you to add or subtract to get the upper and lower limits. It's an extra step I already know you've been doing on the homework, so I'm happy to leave it as is. This will reduce the chance of error as well as save us some time. Let's look at number 3. This is an example of a confidence interval estimate of a population proportion. 100 people were asked if they had health insurance, and 13 said they did not. What is the 95% confidence interval estimate for the proportion of people who do not have health insurance? When working with proportions, we are working with z-values. Since we're working with a z-value, I can just look at the top of the study guide at the commonly used confidence interval estimates, and at the 95%, the z-value is 1.96. Now with proportions, there's no Excel formula that we can use like we did with the means. We just have to use this formula right here and plug in the appropriate variables. But before we can use the formula, we need to find the sample proportion or p-bar. Our sample proportion is found by taking x over n, where x is the characteristic of interest and n is our sample size. Our x is people who do not have health insurance, and 13 said no, divided by our n of 100 people. That gives us 0.13 for our sample proportion. So plugging in our variables, so I'm entering 0.13 plus or minus our critical value of 1.96 times the square root of 0.3 times 1 minus 0.3 divided by our n of 100. And then I'll just solve the right side or the margin of error side. And that gives me 0.066 for the margin of error. And then the entire confidence interval estimate is this statement right here. Our last two problems in this chapter are required sample sizes. One is for the mean and one is for the proportion. So let's look at number 4. Honda wants to estimate the mean household income for college students who own a car. If the company wants a 90% confidence interval estimate with a margin of error of $2,500, what sample size is needed if the population standard deviation is known to be 27,500? So over here on the right is our formula, and you can see the first thing we need is to find our z-value, which I can use the table up at the top for 90%, which you can see at 90%, our z-value is 1.645. So plugging my variables into our formula, our z is the 1.645, and we'll square it. The standard deviation is the 27,500. I'll plug that there. And then the margin of error, or the E, is the 2,500. So I'll plug that in the bottom, making sure to square our numbers. When I plug this into my calculator, I get 327.43. But whenever we're working with required sample sizes, we must always round up because you can't have a 0.43 of a college student. So to make sure we have a good enough sample size, we need to make sure to ask one more student. In this case, we need a total of 328 students. Problem number 5, MiraCosta College wishes to estimate the proportion of students who take online classes with a margin of error of 0.01 with 95% confidence. There is no pilot data. what is the required sample size? So here we have a 95% confidence, so my z-value is going to be the 1.96. And over here on the right, we have our formula. So it still has a z-value that you square, and it still has a margin of error that you square, but you'll notice that since we're working with proportions, we're going to multiply it by the proportion of students who take online classes and multiply it by its complement, or the proportion of students who don't take online classes. Now, the P here is for the population proportion, but if you don't know the true population, you can use a sample proportion. In this case, we have our P bar here. It's interchangeable in this formula. Again, with sample proportions, to solve for it, that's our x over n. But you'll notice in this example, we have no pilot data, meaning we have no sample taken. Since there's no pilot data, we're going to be conservative. In other words, 0.5 chance that students take online classes and 0.5 chance that they don't take online classes. So plugging our variables into the formula, and then plug it into my calculator, and I get 9,604. And I don't have to round it all because there were no decimal values to work with. We got lucky. It was an exact whole number. 9,604 students that we will need to ask whether or not they take online classes. So if you have any questions about Chapter 8, just let me know.